Hello, this is Mr. Buchanan, and today we're going to be going over certain things about triangles and polygons. So, here's a list of the things we're going to be going over. I'm not going to read them on this video. You can read them, and we'll also be going over them as we go through the thing. So, here we go. So, the first thing we're going to go over is the triangle inequality theorem. Now, the triangle inequality theorem is one of those common sense type deals. Uh, Here we have these sides, and the question is, can we make a triangle with these three sides right here? And the answer is no, we can't, because no matter how we try to make the angles, they will always fall short because these two right here are not longer than that third side. So the triangle inequality theorem states that in a triangle, the sum of any two sides is bigger than the third side. So if you have three sides, uh, if you add two of them together, it's always going to be bigger than the third side. The triangle angle sum theorem, we've already went over this. I'm going to kind of just prove it a little bit with this. I'm not going to do a formal proof. I'm going to prove it with a picture and just talk you through it. We already know uh, how many degrees there are in a triangle, or the sum of the measures of the angles in a triangle. We went over that in class before. This is just kind of reiterating that. All right, so I'm gonna mark the angles of this triangle, 1, 2, and 3. All right. Now you'll notice that angle 1 right here, I've drawn some parallel lines, with one of these lines being the base of the triangle. And this angle 1 is a alternate interior angle with this angle right here. I'm going to label it 4. And angle 3, using this transversal, is an alternate interior angle with this one right here. I'm going to label it 5. Now right here uh, we have three lines that add up to form a line. So their measures add up to 180. So the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 is equal to 180 degrees. All right, and uh, I know that angle 1 is congruent to 4, 5 is congruent to 3, so I can just simply substitute the measure of angle 1 for the measure of angle 4, and I can substitute the measure of angle 3 for the measure of angle 5. And we'll see that, hey, the measures of the angles of a triangle all add up to 180. And this works in any triangle. You can do this for any triangle. It doesn't matter. This always holds true. So we're going to kind of take that and we're going to try to make a theorem about all polygons. I'm going to make a table down here to kind of help us to this. So on our table we're going to have the number of sides. Okay, we're going to have the angle measure, or the sum of the angles. It looks like Sam. It's sum of the angles. All right, and then this third thing, I'm gonna have the number of triangles I make. Because we already know if there's one triangle, it's 180 degrees. So with one triangle, that's three sides, it's 180 degrees. So what I'm going to do is I'm going to turn all these other polygons that we have here into just a bunch of triangles. So we take a square, if I just split it, make one diagonal, I get two triangles. And you'll notice that there's no angles except for ones in the corners. So we just add the angles up and we get 360. And it doesn't have to be a square. It can be any kind of quadrilateral. And you can do that to it. So if there's four sides, that means there's two triangles. And that's 360 degrees. So let's go for a pentagon here. So I'm going to make all the diagonals from one corner. And you'll notice there are three triangles. Since there's three triangles, that means it's going to be 540 degrees. All right, so we've got 5 sides, we've got 3 triangles, it's 540 degrees. Give a little degree sign on there. All right, so we'll do one more and then we'll make a conclusion about this. So we make our diagonals for our hexagon over here. You'll notice there's 4 triangles. So that's going to be 180 times 4, which is going to be 720 degrees. So if there's 6 sides, that's 4 triangles, that's 720 degrees. Now one thing you can do, you could do a regression analysis on this and do linear regression and figure out the formula that way. We're just going to look through and see exactly what's going on here. We want to be able to take a number of sides and get the sum of the angles. So one way to look at this is, I know if I get the number of triangles, I can multiply it by 180 and get my sum of my angles. So I want to take the number of sides and see a relationship between that and the number of triangles. So if you'll notice, each time we go from side to triangle, we're just subtracting 2. So I'm going to take the number of sides and minus 2. I'm going to multiply that by 180, and that's how I get the sum of the angles of any polygon, is this formula right here. 180 times n minus 2. I don't really remember this one too well. Usually I just think about it and I go through all the steps to figure it out. Well, I usually go from here to here and then it comes back to me, but you don't always have to remember the exact formulas as long as you know where they come from, or know one way to derive the formula from something else that you know. Next we have a triangle exterior angle theorem. Now the triangle exterior angle theorem is going to be a lot like that first theorem, the second theorem we did, the triangle angle sum theorem. Let's say we've got 3 angles in here, 1, 2, and 3. We add these up and we get 180. So the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. We already know that. But this angle 4 out here, we want to be able to figure out a relationship between it and these angles in here. Well, you already noticed that right here it forms a linear pair with angle 1, which means that the measure of angle 1 plus the measure of angle 4 is going to be 180 degrees. So I want to substitute. I want to take out the 180s since they're both equal to 180, and I'm going to set these two things equal to each other. Measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is going to be equal to the measure of angle 1 plus the measure of angle 4. Now, my golden rule of algebra, what I call the golden rule of algebra, whenever you have an equation, what you do to one side, you have to do to the other. You have to be fair. That's the golden rule of algebra. And that's what I call it, at least. So, in order to be fair, as long as I'm fair, I can do anything to this I want. So I just want to take out the measure of angle 1 over here, and I can do that as long as I take out the measure of angle 1 over here. So I just subtracted the measure of angle 1 from both sides, and this gives me my triangle exterior angle theorem. Anytime you have an exterior angle, which is made by extending one side of your triangle, you end up with an angle whose sum is whose measure is the sum of the remote interior angles. So angle 2 and angle 3 right here are what we call remote interior angles to angle 4. And the last one we have for today, the polygon exterior angle theorem. This theorem is actually going to rely on our polygon sum, the sum of the polygon angles theorem, the polygon angle sum theorem. Sorry, I got tripped up there. So I'm gonna extend all my sides in one direction. So I want to make sure they're all going the same direction. All right, and this is going to make these exterior angles. Now you'll notice that all these exterior angles form a linear pair with an angle inside that polygon. So in this case, I'm using a pentagon. It doesn't really matter what type of polygon you use, though. It will always be the case. All right, so these angles form a linear pair with all the interior angles. So if we just wanted to figure out the measure of all these angles right here, my highlighter doesn't like going in a curve, so that wasn't the best choice. But the sum of all these angles that I've highlighted, including the ones on the outside and inside, I would take the number of uh, angles here, because all these are linear pairs. So take the number of angles and I'd multiply it by 180 for the linear pairs. But I'm not wanting the inside as well. I'm just wanting the outside. So I got to take away all of these interior angles. And I know how to calculate the sum of the interior angles already. I've got to subtract that from it. That's going to be 180 times n minus 2. So to get my exterior angle theorem, I'm going to simply distribute the 180. So I get 180n minus 180n negative 180 times negative 2 is positive 360. Okay, so these two things will cancel out, and I'm left with 360 degrees. So that means that any polygon you have, the exterior angle, the sum of the exterior angles is going to be 360 degrees. And you can kind of work with other shapes to see this. For example, if we have a triangle, we extend all the sides. If you want to kind of calculate this a different way, you can do this with a different polygon as well. It's just kind of a little bit more work. I'm going to label these. Let's see, we got 1, 2, and 3. This is going to be 4, 5, and 6. So I want the measure of angle 4 plus the measure of angle 5 plus the measure of angle 6. Well, the measure of angle 4 is going to be 2 plus 3. So the measure of angle 2 plus the measure of angle 3. Measure of angle 5. I'm using my triangle exterior angle theorem right now, by the way, which means that this exterior angle is the sum of the two interior angles. And that's all I'm doing right now. And the reason I'm doing that will become clear in a second. So I got the measure of angle 6 is equal to the measure of angle 2 plus the measure of angle 1. Now, if we added these three things together, you'll notice there's two angle 3s, there's two angle 2s, and there's two angle 1s. Well, I know if I add these three angles together, I get 360. So if I add up all the exterior angles, well, not 360, I get 180, my bad. Sorry, I didn't mean to confuse anybody. But if I add the interior angles of a triangle, I get 180 degrees. So if I do it twice, like over here, then I get 360. So the measure of angle 4 plus the measure of angle 5 plus the measure of angle 6 has to equal 360. And like I said, this works for all different polygons. So the polygon exterior angle theorem simply says that the sum of the angles is 360 degrees. Alright, so we went over the triangle inequality theorem, the triangle angle sum theorem, the triangle exterior angle theorem, the polygon angle sum theorem, and the polygon exterior angle theorem. Whew, that was quite a bit. Feel free to rewind the video. Make sure you took notes on all this stuff. Remember, this is just to help you out to get ready for that final, and have a good one.